Hey guys, welcome back. Today's lesson is on reversing operations. Our mindset message for today is to find the beauty in math. I say that for this lesson because I think the idea of things that we can do and undo is actually a really beautiful thing, and it connects with our lives like all the time. And that's kind of our theme today. Our learning goals today are we want to be able to reverse a series of steps by backtracking, and we'll talk about more about what that means. And understand the relationship between opposite operations like adding and subtracting or multiplying and dividing, right? Because those operations reverse each other or undo each other. Prior knowledge for today is just remembering what operations are. Remember, an operation is generally just something we do to a number. We're used to thinking of like adding and subtracting and multiplying and dividing. Those are like the four main operations. But honestly, it could be anything. You could just say take any number and add 3. That's a specific operation you're saying to do the whole time. But it doesn't even have to be adding. One operation that's weird is add the digits of the number. So if I give you the number 35, for example, its digits are 3 and 5. So 35, 3 plus 5 makes 8. So we could count that as an operation because it's something we're doing to or acting upon that number. And then also remembering relationships between number tricks and expressions, right? Because the order in a number trick can be used to build an expression, an algebraic expression with a variable and steps that go with it, right? So we'll bring that in later, but let's go ahead and talk about operations and reversing. So some actions are reversible and some are not. I've got one example of each right here. So a reversible action would be opening a door. How do you reverse that? You close it, right? A non-reversible operation I thought of is skydiving. If you've jumped out of a plane and skydived all the way to the ground, you can't reverse that. You know, it's not like a DVD you can rewind it and, you know what I mean? So those are two examples. What I want you to do, and I'm going to look out for this in your notes, is I want you to come up with at least one more example of a reversible one and how to reverse it, and then one that's not reversible. Just some action that you can do. Okay, so go ahead and pause right now. Okay, here's some more things that I thought of. So, reversible. If you eat an entire pizza, that's reversible, technically speaking. Unless you wait too long, I guess, then you can't reverse that, can you? Putting on your socks and shoes. This has actually two things built into it, so we have to be careful here because you can't just be like, okay, take off your socks and then your shoes. Can you imagine trying to take your socks off before your shoes, right? So because of the two steps here, to undo it, the order matters, right? So I need to take my shoes off first and then my socks. That's something to think about. Here's some other non-reversible things I thought about. Sending an email, although these days I don't know. Yeah, because once it's sent, the people can get it, right? So that's not reversible. And honestly, the things you say. I love building these kind of lessons in and connecting them with math, but it's very true that the words we say are permanent, and that can be a really good thing, or it can definitely be a very hurtful thing. There's two proverbs that come to mind that I really like. One of them says, kind words are like honey, sweet to the soul and healthy for the body. Another one says, a person's words can be life-giving water. Words of true wisdom are as refreshing as a bubbling brook. And those are nice, important things to remember here with this. So we got the main idea of reversible and not reversible actions. Let's actually talk about reversibility versus not in the context of math right now. So here are some examples of some reversible and not reversible operations. Okay, so we're talking about operations today. Remember, things you can do to a number, right? So of course, if I do something quite simple like this, if I add 3, how can I undo that or reverse that? Oh, I subtract 3, right? If I add 3 and then I multiply by 8, how do I reverse that? I like to think about the socks and shoes example there again, right? You can't just say, oh, subtract 3 and then divide by 8, because we know those are the opposite operations that undo those things. But the order matters, doesn't it? The last thing I did here needs to be undone first. Again, just think shoes and socks, right? Or socks and shoes. Okay, so this one I have to undo that first. I have to divide by 8 and then subtract 3. So keep that in mind here. We'll talk more about that. Not reversible. These are interesting ones because sometimes students have a little bit of a question or a little bit of confusion when they're thinking about these ones. Let's talk about multiplying by 0. You might think like, okay, well, divide by 0. But then you might think, wait a minute, I think I've learned in the past that you can't divide by 0, which is true, but we'll talk a little bit about why dividing by 0 doesn't make any sense right now. Let's imagine you think of any number in your head right now, and you can go ahead and think of one. And then multiply it by 0. What do you get? You get 0 no matter what, right? So if I didn't know what number you were thinking of, and I said, okay, multiply by 0, you're going to tell me, okay, I get 0. There's no way I could figure out which number you started with, because many numbers, in fact, every single number that exists, would have made the same outcome. And so that's not reversible, because many things could have resulted in the same thing, right? Let's think about adding the digits together. So for example, we could talk about the one I talked about earlier. If here's the number 35, that will give me 8, because 3 plus 5, right? But let's do the same exercise. If I said think of a number in your head, and then I said add the digits, and you told me 8, well, you could have been thinking about 35, but you could have been thinking about 125. Because 125, if you add all the digits, also makes 8. So if we were doing that operation where we said add the digits, and you told me, okay, and I say, and I'm trying to guess your number, and you say, okay, well, when I add the digits, I get 8. I couldn't know your number. So the idea of being reversible means, could I know what you started with? With these things, I couldn't know what you started with. But with these kind of situations, I can go backwards and figure out where you started. So here's where we get to the most important part of our lesson. First of all, a vocabulary word. You need to make sure you record where your vocabulary goes. An operation is reversible if there exists another operation that can guarantee to bring you back to the start. So if you think about those examples we were just using, when we multiply a number by 0, there is not another operation that can guarantee I know what number you started with, right? So this then becomes a tool to use for equation solving. It's really important to have a conversation about equations right now, because even though I know a lot of you students at this point, you can go through the steps and the motions for solving equations. In my experience, I think a lot of students don't really understand what's going on about equations. So you really should be carefully focused right now at this part of the conversation, okay? So let's just start by considering this equation here. 3x minus 8 equals 7. And let's just say, before I do anything else, that I just wanted you to think about this equation and just try to figure out what x makes it true. You could certainly just try plugging numbers in, by the way. You could just put in some numbers, like let's try 5. I think, oh, 5's the answer actually. I didn't even mean to do that. But, you know, let's try 6. 3 times 6 is 18. And then 18 minus 8 is 10, so that doesn't equal 7. So we know that x is not going to solve this equation. It's not going to make this true, right? So the whole goal is to figure out a number here that will make this become equal to 7. And this is how I'm going to introduce to you something really important. Every equation involves expressions, okay? And for these basic type of equations we're going to start studying first, we're going to study ones that have an algebraic expression with a variable on one side and then just a single number on the other side, okay? So I like to think of the expression here as a journey, right? Because what this is telling me is choose a number, multiply it by 3, and then subtract 8. That number is open for us to choose. The world is our oyster, right? We could choose anything we want, and we're going to get all sorts of different ending numbers based on what I choose, right? However, as soon as we turn it into an equation, as soon as we slap an equal sign on here, we turn it into a final destination, right? So the journey now has a destination, and now has an ending point that we want to look towards, and then we're now trying to ask ourselves, oh, how could we get to that ending point? Okay? So I really want you to think of equations like this, where the expression portion is like your journey, and then if there's a single number there, that's like your destination, and we're trying to get there. So it's helpful, I think, if we kind of think of this whole thing as leading to that. So if I started with a number multiplied by 3 and then subtracted 8, and then I resulted in the number 7, how could I go backwards with that? Well, if I ended at 7, to reverse, let's actually reverse these steps. Remember, I need to go backwards and undo each thing. So I'm going to take 7, and then I'm going to add 8, and then here I need to undo that, so then I need to divide by 3. And that is what's going to reverse this. So let's go ahead and take my ending number, 7, and if I add 8, I get 15, and when I divide by 3, I get 5. So let's check this, okay? It seems like where should I put my solution? Let's put it up here. It seems like, based on this, then this gives me 5. So right here, it seems like x equals 5 is my solution. And we can always check an equation by plugging that number back and making sure that it works. 3 times 5 is 15, and that minus 8 is 7. We're good to go. Okay, so this is really important. And this process is actually called backtracking. So one more vocabulary word you need to have down for today. Backtracking is what we just used. It's used to undo multiple steps, but in reverse order. That's a really important thing, right? Remembering the order has to go in reverse. Here's another visual for that equation that I think might be helpful for you to add into your notes, actually. You can almost think of these as like little machines, and the machine does a certain operation, and then the next one does another one. So if I'm starting with an unknown number, that's kind of what this is saying, right? This is saying I don't really know what it is right now, but when I do this stuff, I end with 7. And so I can think, if I multiply 3 and then subtract 8, then out comes 7. So if I send it backwards through, let's call this the reverse machine, then what I do is I'm going to add 8 on the way back and then divide by 3. So 7 plus 8 is 15, and that divided by 3 is going to give me the x that I started with. And after doing that, we can then find, aha, this number must have been 5, right? Okay. One other important thing to know about equations is that even if this ending number is another variable like y, and we typically use x for the thing that goes in, and we use y for the thing that comes out. Not that you have to, but that's kind of the standard thing. Sometimes it confuses students to think about this one versus the other one. But I just want you to remember that when I had the 7 over here before, right? All that was saying is that was a specific choice we made of what if we ended there, right? You could ask anything. What if we ended at 18? What if we ended at -2 or whatever, right? And so by putting another variable here, we're just saying this now represents all possibilities of ending numbers we could ask about. And then this process of undoing is still going to be the same. Y plus 8, and then divide that by 3 to get 8x. And that relationship that's formed between those two things is actually super important here. We will come back to this at some point, but I do want to write, so here's the expression that goes with the forward direction, and the expression that we can write that goes with the other direction is if I go reverse, that means that y plus 8 divided by 3, I like to use the fraction bar for that, is going to get me to x. So this here, okay, represents that reverse direction. But actually this is bothering me, my coloring is not the same. Actually, this relationship just represents the reverse of that, but they're really expressing the same relationship, okay? And we're going to talk more about that later, but I thought I would point that out. So one last thing for you to do, just to pull everything together from today, I want you to do this yourself. Write the steps to backtrack this expression. 6x plus 2 all divided by 3. I've written the forward direction like it's a number trick for you, because this says choose a number, multiply by 6, add 2, and then divide by 3. Go ahead and write the reverse now. Okay, let's check your answer. Because we did this last, I'm going to need to undo it first. So multiply 3 first. Now we got to go to that. Subtract, right? We have to undo that, so we're going to subtract by 2, and then here we multiplied by 6. So we need to divide by 6, and then we're going to get to my starting number. So that's it for our lesson today. Happy math, and we'll see you next lesson.